Why does time travel keep fascinating us? Even after so many years of stories in books, movies, and art, it's because time travel touches on our deepest wishes and the big questions we can't answer. We dream of getting second chances, fixing past mistakes, or reliving happy moments. We're curious about history and want to see important events with our own eyes. We also want to peek into the future and see where humanity is headed. Time travel makes us think about what reality really is. It makes us question cause and effect and whether we have free will or if everything is determined. Time travel paradoxes like the grandfather paradox show how messing with time can create chaos and unexpected results. But it's this mystery and the mind-bending possibilities that make time travel so interesting. It pushes us to think deeply and question everything we know about the universe and our place in it. Time travel is a popular theme in science fiction, but it actually has roots in real scientific ideas. What was once just fantasy is now being studied by scientists as a real possibility, though it comes with many challenges. Albert Einstein, a famous physicist, helped lay the groundwork for the scientific study of time travel. In 1905, Einstein's theory of special relativity introduced the idea that time is not the same for everyone, but depends on how fast you are moving. His theory says that time slows down for objects moving close to the speed of light, a concept called time dilation. This means time can stretch and compress like a fluid. Although traveling at the speed of light seems impossible now, Einstein's theory suggests time travel could be possible on a large scale. In 1915, Einstein's theory of general relativity introduced the idea of space-time, a fabric that can be warped by gravity. According to Einstein, this warping of space-time is what we feel as gravity. Large objects like stars and black holes create big distortions in space-time, which might make time travel possible through things like wormholes. Stepping into the unknown, a journey through time. Imagine a shortcut through space and time, connecting faraway places. This idea is called a wormhole, predicted by Einstein's theory. Wormholes could let us travel instantly and even journey through time. Though it's just a theory, it fascinates scientists and writers. These shortcuts could break the speed of light, hinting at real-time travel. But wormholes are still just ideas with big challenges to make them real. Gravity and instability make them hard to use. Despite the problems, wormholes and time travel inspire science and stories. The quest for time travel continues to captivate people for generations. Einstein's idea, time as a river. Albert Einstein changed how we see the universe. Before Einstein, time was seen as constant, like a ticking clock. Einstein showed time is more like a flowing river. His theory showed time is relative. Imagine twins, one on Earth, one traveling fast in space. The twin in space ages slower because of time dilation. Time dilation is real and can be tested. Atomic clocks prove time dilation in experiments. Time can stretch and compress with motion. Einstein's idea made time travel seem possible. If time flows differently, it might be bent or traveled through. The fabric of reality, gravity's cosmic dance. Einstein didn't stop with special relativity. In 1915, he came up with general relativity. This theory changed our view of gravity. It's not a force, but a bend in space-time. Imagine a bowling ball on a trampoline, making a dip in the surface. Big objects like stars and planets bend space-time like this. Smaller objects roll towards the dip, just like they move towards big celestial bodies because of space-time's shape. This bending of space-time is what we feel as gravity. It's not a force pulling us down, but the shape of space-time guiding us. Just like a river's path changes with its bed, time changes with space-time's shape. General relativity says time moves slower in strong gravity, like near big stars or black holes. This idea has been tested and proven, showing Einstein's genius in understanding the universe. Wormholes, tunnels through space and time. Einstein's theories of relativity were groundbreaking, but they didn't directly predict time travel. However, they gave us the tools to think about these amazing ideas. One such idea is the wormhole, a theoretical tunnel connecting two far-apart points in space and time. Picture the universe as a big sheet of paper with 2 points far apart on it. Now, fold the paper in half, bringing those 2 points close together. A wormhole would be like a small hole punched through the folded paper, making a shortcut between those 2 points. While wormholes are just theoretical, they aren't ruled out by the laws of physics. They could allow for instant travel between far-off parts of the universe, avoiding the speed of light limit. And if the two ends of a wormhole were at different times, traveling through it could mean traveling through time. The idea of traveling through wormholes, maybe even to the past or future, excites both science fiction writers and scientists, but making, stabilizing, and using wormholes is very difficult, so for now, they remain a fascinating theory. Time dilation, a journey to the future at the speed of light. Wormholes are interesting, but Einstein's special relativity gives us a real way to think about time travel. Time dilation. Time dilation means time slows down for things moving close to the speed of light. Imagine getting on a spacecraft that can go almost as fast as light. As you get close to light speed, time would start to change around you. For every day on Earth, only a few hours might pass on your fast-moving spacecraft. The faster you go, the more time slows down. When you come back to Earth, you would be younger than the people who stayed. While many years passed on Earth, you would have felt only a short time on your spacecraft. You would have traveled to the future, but getting close to the speed of light is very hard with today's technology. It would need a lot of energy and new kinds of engines. Time dilation is not just an idea, it's been proven by many experiments. It shows us that time is not fixed but can change, making it an exciting area to explore. Our journey into time travel leads us to black holes where normal physics don't apply. These giant objects bend space-time, creating areas with strange physics. When you cross the event horizon, time acts strangely. To someone watching from outside, your fall slows down and almost stops. The singularity might be where space-time breaks down. What lies beyond is unknown, a puzzle for future scientists. We usually think of time as moving in a straight line, but that might not be true. Einstein said time can be bent and stretched. Some people even think time might not be real. Time could just be something that comes from a deeper reality. This idea changes how we think about the world. If time isn't real, then cause and effect don't make sense. Past, present, and future might all exist together. This changes how we understand the universe. Time travel is fascinating, but it's full of confusing problems that can mess with logic and cause and effect. These problems aren't just for fun. They show how hard it is to make time travel fit with what we know about the universe. Think about going back in time and accidentally causing your younger self to die. Would you disappear too because you changed your own past? Or what if you changed a small event like stopping your grandparents from meeting? Would that small change create big differences in the present? These are just a few examples of the strange problems we face when thinking about time travel. They make us question how cause and effect work, how time moves, and what reality really is. Some might think these problems are just for fun, but they remind us that changing time can have big, unexpected results. If time travel ever becomes real, understanding these problems will be key to keeping the timeline and the universe stable. Among all the time travel puzzles, the grandfather paradox is the most famous and thought-provoking. This idea, common in science fiction and philosophy, challenges our understanding of cause and effect. Picture a brave time traveler going back in time, driven by curiosity or adventure. This traveler has a dark plan to stop their grandfather from meeting their grandmother. The paradox comes from the strange results of this plan. If the traveler stops their grandfather from meeting their grandmother, they would never be born. But if they were never born, how could they travel back in time to do this? The grandfather paradox shows the danger of time travel, reminding us that changing the past could erase our existence. It makes us think about how our actions, even small ones, can have big effects, possibly changing the future for many generations. The butterfly effect. Ripples in the river of time. The butterfly effect shows how small changes in the past can have big effects. Even tiny actions can spread through time like waves in water. A butterfly flapping its wings in Brazil could cause a tornado in Texas. It shows how everything is connected and how sensitive systems are. In time travel, the butterfly effect is very important. A time traveler could change history in unexpected ways. It's best not to change the past to avoid problems. Free will versus determinism. Are we in control of our future in a time-traveling world? Time travel makes us question, do we have free will or is everything already decided? Can we change our future or are we just following a set path? Determinism says everything is already decided, which clashes with time travel. If the future is already written, how can we change it? Would trying to change the past be pointless, with things going back to how they were? Free will gets a boost from time travel. If we can change the past, maybe we aren't stuck with fate. Our choices might change the future, affecting our lives. The debate between free will and determinism is tough. Time travel makes us wonder, are we in control of our future or just going along for the ride? Closed time-like curves, journeying through time's loophole. Wormholes might let us travel huge distances in space, but there's another idea from Einstein's equations that could let us travel through time-closed time-like curves. Think of a racetrack, where the start and finish lines are the same point. A car on this track would keep looping back, crossing the same point in space and time over and over. This is what a closed time-like curve is, a path through space-time that loops back on itself, allowing time travel. Closed time-like curves aren't ruled out by physics, but they're still just a theory. They would need extreme conditions, like the strong gravity near rotating black holes, to bend space-time so much that time loops back. If these curves exist, they might let us travel through time, but with big limitations. A traveler on a closed time-like curve couldn't change the past because their actions would already be part of the loop. They would be moving through a fixed timeline, like an actor repeating the same scene again and again. Can the past be changed, or is it written in stone? Can we change the past, or is it fixed and unchangeable? If we could go back in time, would our actions change history or follow a set path? Changing the past is full of problems. Wouldn't changing the past create paradoxes and mess up cause and effect? The grandfather paradox shows the risk of erasing ourselves. A fixed past seems to clash with free will and the universe's changes. Are we just passengers on a set journey? Maybe the past isn't completely unchangeable. Our actions now, influenced by the past, shape the future. The eternal now. Time is not just a straight line, it's like a big ocean where all moments exist together. Imagine stepping out of the river of time and seeing all of history at once. This idea makes us rethink what we know about time. The quantum realm, where time flows like a river delta. To understand the idea of the eternal now, we need to explore the quantum realm, where the usual rules of physics don't apply and reality seems to shimmer and dance. In this tiny world of particles and probabilities, time acts in a fluid and unpredictable way, unlike our everyday experience. Here, particles don't move in straight lines like balls on a pool table. Instead, they exist in a cloud of possibilities, with their position, speed, and even their past and future uncertain until we observe them. It's as if at this basic level, time splits into many paths, like a river delta, creating multiple possibilities. This unpredictable nature of the quantum world, where many outcomes exist until we measure them, suggests a deeper truth about time. Maybe time is not a fixed structure, but a fluid tapestry made of many possibilities, always changing as quantum events happen. The implications of this idea are significant. It suggests that the past might not be set in stone and the future is not predetermined. Instead, every quantum event, every interaction between particles might create ripples in reality, leading to new branches in the river of time and an ever-growing tapestry of possibilities. Combining Einstein's relativity and quantum mechanics gives us the block universe theory. This theory, called eternalism, says the universe is a fixed, four-dimensional block of space-time, holding all of history from start to finish. In this block, every moment from the Big Bang to the end of time exists at once, like frames in a movie reel. Think of this block universe as a huge, detailed sculpture with every event, person, and thought carved into it forever. If all moments exist forever, then changing the past or the future doesn't make sense. If the block universe theory is true, why do we see time as moving forward? The answer is in how we experience it. Like a character in a movie only sees one frame at a time, we see the block universe one moment at a time, making it seem like time is passing. This is necessary. Imagine living your whole life from birth to death all at once. It would be too much. Seeing time in a straight line helps us understand the big picture of the block universe. The block universe has big effects on how we see our mind and free will. If the future is already set, do we really have free will? Are we just acting out roles that are already decided? Some say the block universe means we don't have free will, and our choices are just an illusion, but others think free will and determinism can exist together in a timeless universe. Picture your mind as a field, spread out across the block universe, feeling every moment at once. Free will might be about choosing which path to experience in the block universe, not changing the past or future. Our journey through the science of time travel has taken us from everyday life to the idea of a block universe. We've faced paradoxes and questioned what time really is. Yet time remains one of the biggest mysteries. Maybe true wisdom is not in solving every secret of time, but in accepting its mystery and living fully in each moment. Whether time is like a river, a tapestry, or a block, our journey through it is a precious gift to enjoy. Time travel has captured our imagination, leading to endless questions. How would we know if people from the future are here? Maybe they would look different, or maybe they would fit right in. Some think we can find proof of time travelers in old photos, films, or artwork. Many claims are just imagination, but the idea of time travelers leaving clues is interesting. If time travel is real, wouldn't people want to see important moments in history? Some people believe time travel is real because of strange old objects found in history. These objects might show that advanced technology existed long ago, possibly brought by time travelers. One well-known example is the Antikythera mechanism, an ancient Greek device used to track the stars. Another example is the Baghdad battery, which hints that people knew about electricity much earlier than we thought. While some say these objects can be explained by a known history, they still spark curiosity and debate. Throughout history, civilizations have come and gone, leaving behind clues to their existence. What if some lost civilizations were changed by time travelers? Could sudden jumps in technology be because of them? Imagine time travelers giving advanced tools to less developed cultures, causing quick progress, or maybe they tried to stop a disaster, but ended up causing a civilization to fall. If time travel were real, even good intentions could have big effects, leaving behind mysteries. The Mandela effect mixes up reality, memory, and different timelines. It's named after the wrong belief that Nelson Mandela died in prison in the 1980s. It means shared false memories. Examples are the spelling of brand names, details of logos, and historical events. Even though memory can be wrong, many people having the same false memories make some think about alternate timelines. The Mandela effect shows how our perception can change and how hard it is to tell fact from fiction. Time travel sounds scary when we think it might have already changed our history. What if time travelers have changed events to make sure things happen a certain way? Imagine a secret group working in the dark to protect the timeline. Could they be stopping disasters or guiding us in a certain direction? If time travelers are here, are we in control of our future or just part of a bigger plan? If time travelers are changing events, how can we find out? Looking for strange events, sudden new technologies, or unlikely changes in history might show their actions. Checking for information or technologies that seem to appear from nowhere could also give us hints. Finding proof of time tampering is hard, but questioning what we know about the past can help us understand time better. The search itself can show us how complex time is and how tricky it is to find the truth. Embracing the unknown. Our journey through the science of time travel has taken us through many strange and exciting ideas. We've looked at how the past, present, and future are connected. From Einstein's big ideas to the mysterious world of quantum mechanics, we've seen a universe that's stranger and more amazing than we thought. We've thought about wormholes and the puzzles of time travel. The butterfly effect shows us that small actions can have big impacts. Time is still the biggest mystery, the stage for the universe's story. The quest for understanding continues. We are amazed by the universe and have many questions. Can time travelers change the past? Is the future set or full of possibilities? Can we match the idea of a fixed universe with how we feel time? Will time travel stay a theory or become real? Scientists are always learning new things. Understanding time is a never-ending journey. It's about understanding ourselves and reality. The future of time travel, a journey still unfolding. Time travel shows our endless curiosity and desire to go beyond limits. Thinking about time travel helps us understand the universe and our place in it. As we explore space, we might find new clues that make time travel possible. Even if we can't time travel, learning about it is still valuable. The journey and exploring ideas are what really matter. Understanding time helps us appreciate the present, where we can make a difference. The future of time travel is a journey still unfolding, made from scientific discovery and human imagination. Whether we visit the past or enjoy the present, time travel will always inspire us.